Hi, so this is Geometry Review 5. We are beginning with question number 10. A solid rectangular prism with dimensions 5, 10, and 6 is cut into square prisms of side length 1 centimeter with thickness of 1 mm. So 1 mm is 0.1 centimeter. What is the most number of square prisms that can be made from the bigger prism? Okay, so that's 5, 10, okay, and 6. Yeah, and we have 0.1 centimeter, so 1 mm, 1 mm, tiny square prisms. Yeah. So, so we know that we have 5, 10, 6 divided by 0.1, 0.1, 0.1, right? That's how we work it out, correct? Okay. So that is 50 into 100 into 60. All right. So that is 30 into 1, 2, 3, 4 zeros. That is 300,000. So what are we doing wrong out here? All in centimeters. Okay. I forgot this part. Side length is 1 centimeter. Square prism of side length 1 centimeter with thickness of 1 mm. What is the most number of square prisms that can be made from the bigger prism? Side length 1 centimeter. Okay, so if I were to consider a prism, square prism, side length of 1 centimeter, so that's a square, and thickness of 0.1. So it is not a cube. Right, so that's the error. Hmm. Okay. I get it. So basically, this is where things are going different. I consider it to be a square prism. I consider it to be a cube of 0.1, 0.1, but that's not the case. So what we need to do is we will first break down the 50 centimeter square, 5 into 10. That 50 centimeter square with we'll divide it by 1 into 1 centimeter. So that way we know that there are 50, you know, so this is 1 centimeter prism basically. And then another one, and then another one, and then another one, and then another one. So like that, there are 50. Yeah. So 50. And now this 6 centimeter, yeah, 6 centimeter, we need to divide by 0.1 because this 6 centimeter is like 60 mm. 60 mm with 1 mm. Understood? Or or you can take it as 50 into 6 by 0.1. So 6 centimeter divided by 0.1, we'll come to know how many layers, how many thicknesses can we afford. So that is 60 layers we get, 60 layers we get like that. So 50 in one layer. So therefore, 60 layers, how many? So that'll be 3000 in 11. A solid cube of side length 5 centimeters. So now this is a proper solid cube of side length 5 centimeters. 5, 5, and 5 is painted red on all its surfaces. So it's painted red on all its surfaces. There are 6 surfaces, so it's painted red on all its surfaces. Then this solid cube is cut into smaller cubes of side length 2 centimeters. So side length 2 centimeters. This is 2 and 2, and this is 1. So 2, 2. Okay. Smaller cubes. So these are cubes. Yeah. 2 and 2. And so out here also, so this is entire 1 centimeter layer is this entire part is chucked out. Even this entire part is chucked out. Okay. And in the bottom also, this entire layer is chopped off. Correct. So then we have 1, 2, 3, 4, 5, 6. So there will be something out here. So sorry for this ugly drawing, but basically what we have is 4 over here on this first you know layer till here. We have 4 and another 4 out here total. So there are 8 cubes. Now all of these 8 cubes, if you see, they are painted red. So find the number of small cubes with no red face on it. So there are 0 because all the smaller cubes of length 2 centimeter will have a red face on it. Okay. So let me discuss one more question similar to this. So instead of 2 centimeters, let's say it was 1 centimeter. Okay. So in that case, you could have an answer. All right. So then if you have 1 centimeter, so 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Yeah. So like that, we have 125 cubes forming. Yeah. 25 on each floor. So there are 5 floors. Ground plus 4 or 5 total layers. 25 on each layer. So 125 cubes. And these are all painted red. These are all painted red. So in that case, the ones which are inside, yeah. So inside, what you'll see is that avoiding the first layer and the last layer and the side layer. So if I do the drawing with the blue color, this is the inside portion. This is the inside portion. All right. So there are 9 cubes which are inside, and those 9 are basically having 1, 2, and 3, 3 layers, because top and bottom layers are all there, and so are these side ones. So basically 9 into 3 27 cubes you will have which will have no red face on it. So because of my drawing, you might not be able to figure out. Draw your own cube and try to figure it out. Okay. And also you need some imagination. Right. Question 12. A right circular cone standing upright. So right circular cone just means that it is, you know, an upright tip which coincides with the center. So basically, you can have cones like that also. So this is not a right circular cone, but this is, all right. So a right circular cone standing upright on its base, yeah, having diameter 9 centimeters. So the radius is 9 by 2. Is cut from the top to form a smaller cone. Yeah, cut from the top to form a smaller cone with base having diameter 4 centimeters. So this is 4 centimeter. Find the ratio of the total surface area of the small cone to the big cone if the height of the bigger cone is 12. So height of the bigger cone is 12. So out here, again, we'll have to use the imagination that consider it like a right triangle. Right triangle where this is 12, yeah, this is 4, and this is 9. Okay, yeah. So there are two similar triangles because this angle is common, 90 is common. Therefore, the third angle will also be common, correct? So we can use similarity out here, corresponding sides. So consider A, B, C, D, E. Okay. So triangle ABE to triangle ABD, ACD. Okay. So the corresponding sides are AE to AD, which is equal to BE to CD. So AE is X, AD is 12, BE is 4, and CD is 9. Therefore X is 48 by 9, or 3 threes are 3 16s are 16 by 3. So this height is 16 by 3. We have to find the ratio of the total surface area of the smaller cone to the bigger cone. So we don't need to really find out X. Yeah, all we need to know is the ratio 4 is to 9. Because that 4 is to 9 ratio, yeah, is the ratio of the heights also, the ratio of the diameters also, ratio of the radii also. Yeah. So if we simply take the square, then we'll get the ratio of the areas. And if you were to cube it, we'll get the ratio of the volumes of the smaller cone to the bigger cone. Therefore, my answer is 16 is to 81 E. But I want to sit down and calculate the actual answer. Correct? So what I'm going to do is I'm going to use 16 by 3 as my height and my total surface area. Okay, I'll just use this surface, this little portion out here to do the math. Okay. So let's take the total surface area, that is pi RL plus pi R square. So that for the smaller cone, yeah, ABE, let's just call it ABE, yeah, smaller cone, or let's just call it smaller cone. small total surface area. So pi, yeah, radius is 2 centimeters because the diameter is 4. And this thing is the slant length. Okay, this is the slant length they're talking about. So if this is 2 and 16 by 3, then slant length will be, we'll have to do the slant length calculation. I'll do it out here. So slant length L square is equal to 2 square plus 16 by 3 square, 256 by 9, and that is 4. Okay. So we'll take it as 2 square plus 256 by 9. We'll just take it upon 9. So 9 4 are 36 plus 256. That's 280, 292 by 9. Okay, 292 by 9. Square root of that. Half. Okay. Plus pi, radius is 2. So 4, 2 square. Okay, so that's my area of the small one. And that's what they're asking. Total surface of the small cone to the big cone. And the big one, the TSA, is pi RL. So pi, radius is 9 by 2. And the slant length is, so we know that it is 9 by 2. L square is 9 by 2 the whole square. All right. And the slant length will be, no, wait a minute, my bad. Yeah, 12 square. 12 square. So that's 81 by 4 plus 144, right? So that would be on 4, 81 plus 444 times 4. My God. So 44s are 160, 176, and 400, 576. So that is 657. Okay. Yeah. 4 fours are 16, 17, 4 on the 4 and 5, 576, 5, 650, 657. Okay. 657 by 4 and square root it. Plus pi into 9 by 2, which is 81 by 4. Squaring part. Okay. So the ratio therefore would be what? See, we'll have to first reduce the big one. All right. So we have this 2 coming out. So pi into 9 by 4 and then 657 raised to half. Right. Okay. Plus 81 by 4. I've taken the pi outside. And this one out here is pi. Yeah. And then I have 2/3 because that 9, 3 comes out. 292 raised to half plus 4. Okay. So pi and pi cancels. So then ultimately I have this upon this. Right. Very complicated calculation part, but we'll solve it anyway. So let's do the math on it. Again, I require some white space. So let me use this space out here. Okay. So I have 2 by 3 and 292 is 146. Okay. Okay. And 146 is 72. So 4 into 72, like that. 74 are 280, 2 fours are 8. So 282 happens. Huh? Okay. 292 I need. So half of this is 146. Correct? Well, 146. And 146 is 73. My bad. 73. Okay. 4 into 73. Okay. 4 into 73. So that 4 square root of that is 2. Correct? And then plus 4, obviously. So I'm just trying to reduce this part only. Yeah. So that 2 comes out. So it becomes 4 by 3. Okay. Then 73 raised to half plus 4. That thing over 9 by 4. And this is 11 and 7, 18. 18. So it's a multiple of 3. So let me see if I can break this down. 9 over 4. 3 twos are ones are nines are 10, 12. So again, it can be broken down. 3 sevens are threes are. Oh, lovely. So I got 3 square. So out here, I'm getting 9 over 4 into the 3 part is coming out. 3 part is coming out. And then I'm getting 73 raised to half. Correct? And then 81 by 4. Okay. Right. So since both are out of 4, I can add up the 81 and the whole thing becomes 4. And out here, the whole thing 4 can come out. Okay. My God, I need more space to work out the math. So I'll use this space out here. Okay. So remember, I can take out the 4. Yeah. I take out the 4 and I can have 73 raised to half. Okay. And I can say plus 12. That way I can take out 4 by 3. Yeah. Okay. And out here, I can take out 9 over 4 outside. And I have, in fact, 27 over 4. I can take out 27 over 4 outside. Yeah. Then I have 73 raised to half. Right. And out here, 3 by 4 inside. Right. So 3 only inside. Okay. So that's what I'm getting. Yeah. So as you can see, this 16 by 81 I'm getting, and these two actually cancel out. So some calculation error, but I'm getting very close to it. I'm getting very close to it. Some calculation error I must have made. Yeah. 4 by 3. This is 9 by 4. And then 3 into 3 into 2 into 73, right? 3 into 3 into 73. 81 by 4. So if I've taken out 27 by 4, fair enough, then this is plus 3 inside. And out here, if I've taken out 4 by 3 out, right, it's 2. And then that 2 comes out, becomes 4. 4 by 3, this 3 whole thing. So I have 4 and then 73 and a half plus 1, I think. Oh, yeah, my bad. My bad. Out here, see this part out here, this one out here, if you see this part, yeah. Once I remove 4 by 3, then 73 comes out and this one becomes 1. So this would actually be 3. Okay. So now these two cancel out. So this answer gives me 16 by 18, 1. And very calculative. So use the shortcut method. Yeah. Sorry about that. So time consuming questions, learn how to save your time by using similarity technique because actually solving it is quite cumbersome. Okay, 13th question. A hollow pyramid with a square base. So I have a square base. Okay, let's just draw it this way. And this is my hollow pyramid. Okay, yeah, with side length 5 centimeters. The vertical height from the center. So now I'm just giving you a front view of it, right? So this is 5, and this is the top part. Okay, it's constructed such that the vertical height from the center of the base to the top. So center of the base to the top. Yeah. So this is the top, and the center of the base is this part. This is the center. Yeah. And this blue line is the top to the center of the base. Okay, like that is 13. So this blue line is 13 centimeters. Yeah. Find the length of the longest possible straight stretch found on the pyramid. So the longest possible straight stretch is from here to here. All right. That is this portion to one of the corners. Any corner you take, any of these blue lines you take. Okay. So I know that if the square base is if the side is 5 centimeters, then the diagonal length from here to here. So in the red, I'll put the diagonal length. This is square base. Okay. So this diagonal length is 5 root 2. Yeah. And in between, when it touches the base, it will be 5 root 2 upon 2. Okay. Half the diagonal. Correct. And that half the diagonal and this 13 and this black color line or green color line, I'll put it green color line, is what I need to find out, the green stretch. So basically, I've got a 13, I've got a 5 root 2 by 2, and this is what I need to get, x. And we assume that this is 90 degrees, so x square is equal to 13 square plus 5 root 2 upon 2 square. And that's how we get the longest stretch. So that's 169 plus 25 into 2 upon 4. So 2 and 2 goes. So we have 2, yeah, 169 and 50. Correct. No, sorry. 170 and 170, 340. So 338 plus 25 upon 2. So that is 350, 363 upon 2. Okay. Right. So 363, they are multiples of 3. So 3 into 1 to 1. Yeah. Right. And remember, it's x square. This whole thing is x square. And therefore, x is what? X is root 3 over root 2 into 11. So B is my answer. All right, two more questions and we're done. Question 14. A hollow cylinder having diameter 15 centimeters is constructed such that all vertices of a cuboid touches the inner circular walls and bases of the cylinder when the cuboid is placed within it. So cuboid, I'll take it as a red color. So consider this cuboid where it touches, yeah, the inner circular walls and everything. If the cylinder is 200 centimeters tall, so this is 200 centimeters tall, and so is the cuboid inside it. Find the volume of the largest cone that can be fit into the cuboid. Okay, so first of all, what we need to understand is that look at this blue color. I'll draw the cone upside down. So this is my cone having the diameter similar to the cuboid. Cuboid it's using now, the word cuboid. Okay. Now remember, in a circle, if the cuboid has to touch the walls, then it will be a square like this. And bases of the cylinder when the cuboid is placed within it. The cylinder is 2 centimeters. Find the volume of the largest cone. Huh? So my bad. To find the largest cone, we need to make sure that this cuboid is a square and not a rectangle, because within a circle, the square will have the largest area. Okay. Now within that, we need to have a circular cone. So understand this. Green color is the circle. Within that circle is the cuboid, this one. So the diagonal of the cuboid is 15 centimeters, and therefore the diameter of the circle is 15 centimeters. Okay, correct? No, my bad. The diagonal is 15 centimeters of the square cuboid. This is 15 centimeters. Yeah. So therefore the 15 by root 2, 15 by root 2 will be the side of the square. Okay. So 15 by root 2 is the diameter of the inner cone. 15 by root 2. And half of that is the radius of the cone, and we have to find the largest cone. So then the volume is 1/3 pi r square h. So 1/3 pi r square is 1 by 2, 15 by root 2, the whole thing squared into the height, which is 200. Now once again I'll explain you. See, they are clearly stating the diameter of the cylinder is 15 centimeters. That diameter is the diagonal of the cuboid, the surface area of the cuboid. So the red thing that you see, the diagonal is 15 centimeters, and therefore the inner circle inside it, the blue color circle, will have a diameter which is side length. So the side length of the red square is 15 by root 2. Okay, and that diameter, half of that is the radius, and therefore we have this equation. So therefore the volume is 1/3 pi 1/4 225 by 2 into 200. So 2 goes with 100, 8 9. So 3 goes into this 75 times, 4 goes into this 25 times. Therefore my volume is pi 75 25. Correct? So 75 into 25 is 25 5s are 125, 25 7s are 175, 185, 187, 1875, 18755. B is the answer. So my questions, I don't know, somehow I've designed it to be more calculative. Yeah. And there's this hidden knowledge in this question that if the cylinder is 200 centimeters tall and the cuboid touches the inner circular walls and bases of the cylinder when the cuboid is placed within it, if the cylinder is 200, find the volume of the largest cone that can be fit into the cuboid. So we assume that the cuboid, to have the largest largest cone, we assume that the cuboid is going to be having a square surface, basically. Like it's a square prism, square rectangular prism, basically. Okay, last question. A sphere of diameter 30 centimeters is constructed such that all the vertices of a cube touches the inner circular wall of the sphere when the cube is placed within it. Find the length of the body diagonal of this cube. So see, in this question, suppose you have a cube placed in it. Yeah. Okay. Right. Now on a 2D page, it's very difficult to draw this cube. Yeah. But assume it's something like this cube. Yeah. And around it is, this is placed inside a spherical shaped structure. Yeah. Somewhat like this. Okay. Understand it this way. Then they're saying the body diagonal of the cube is from this point to this point, which is also passing through the center of the cube. And therefore it becomes the diameter of the sphere itself. All right. Body diagonal will pass through the centermost point of the cube, which is also the centermost point of the sphere. And the body diagonal of this cube is also the diameter of the sphere. Therefore, the answer is 30 centimeters. Okay, again, a very intuitive question, something that you would probably need to imagine. Okay, one last question I'll ask about the hemisphere, and then we'll wind up. So consider a hemisphere. Okay, and within the hemisphere, there is a right circular cone drawn. The right circular cone is drawn such that the base of the hemisphere and the base of the right circular cone, they overlap. So the question is, find the height of the cone to the radius of the hemisphere. Find the ratio of the height of the cone to the radius of the hemisphere. So the answer out here is, as you can see from the drawing itself, that both the height and the radius is x and x. So the answer is 1. That's it. We have completed the review 6, geometry review 6. Unfortunately, it went up to 6 reviews. I wanted to finish it in 4 reviews, 3 reviews at the most. So that's it for today. Thank you very much. You'll find you have the quiz under review 1 of geometry, quiz under review 2. You'll have a quiz under review 3, and you'll have one quiz under review 4, and that's about it. 5 and 6 is just part of the same geometry. So total 4 quizzes are there within this description of the video. Yeah, thank you very much. I think next we'll consider uh, data interpretation and logic questions, or maybe sequences. I'll just see what I can do. Thank you.